So for problems 21 through 23, we're actually going to look at some proportion examples where there is an unknown or a variable included in one of the two ratios. So in problem 21, we have the ratio 5 divided by the variable x. So that variable is what we're going to try to solve for, is equal to the actual ratio of 12 to 8. So whenever we have a proportion with an unknown, the way that we solve for that unknown is by initiating with the actual cross product. So we're going to cross multiply, and we're going to take 5 times 8 on the downward diagonal, x times 12 on the upward diagonal. 5 times 8 just gives us 40. X times 12, we just write that more simply as 12 times x. It is an expression. The variable x is still unknown. We're going to try to solve for that variable x. And since, before we do that, I should say that if you have an equation, 40 equals 12x, remember that you can always rewrite an equation if it's more convenient to you by swapping what's on the left and what's on the right. So 40 equals 12x is the same thing as saying 12x is equal to 40. Now remember that our whole goal here is to find what that value of x is. We don't know the value of x because it's multiplied by 12. If we want to undo the effect of multiplying by 12, we need to do the inverse operation of multiplication, which is division. If you notice here on the left, I divided 12x by 12. And in order to keep the solution to the equation the same, in order to basically utilize the properties of equations, if I divide the left side by 12, I also have to divide the right side by 12. Dividing 12x by 12 will leave me with just x. On the right side, dividing 40 by 12. Well, 40 by 12, 12 doesn't go into 40 evenly. So really the best way to handle that problem would be to just treat it like an improper fraction. Remember, it's improper since the numerator is greater than the denominator, and try to reduce it to simplest form or lowest terms. Now, how could you take 40 divided by 12 into lowest terms? Well, many of you may choose to do it in 2 steps. Recognize that they're both even, take out one factor of 2. But if you do that, you'll get 20 over 6. They're still going to be even, so you have to take out another factor of 2. Alternatively, you can just cancel a factor of 4 initially. 40 divided by 4 is 10. 12 divided by 4 is 3. So hopefully for that, you get the answer 10 thirds. If you did want to plug that in and check it, you certainly can. But what you would have to do is be careful with your rules of fractional arithmetic, which we can talk about if you want to send me an email or talk about in class. So for 22, we have the actual proportion, 13 over 8 equals 39 over y. So what they're trying to show you here is that unknown variable, it can be in any of these 4 spots. In addition, you don't have to write the variable as x. You could write it as y. Regardless, you're going to solve this the same way. You're going to apply the cross multiplication or cross product rule. On the downward diagonal, 13 times y is just going to give me 13y. On the upward diagonal, 8 times 39 will just give me 312. How do I solve for y? Well, if y is multiplied by 13, I undo that by doing the inverse operation of dividing both sides by 13, which gives me that y is equal to 24. So let's look at question 23 here. We have the actual proportion, x divided by 7 equals minus 25 over 14. Why is this one a little bit different? Well, our unknown x went in the numerator instead of the denominator. In addition, we have a negative number, but we will see that we're still going to use the same procedure. Namely, we're going to cross multiply. On the downward diagonal, x times 14, the preferred way to write that is 14x. On the upward diagonal, 7 times minus 25. Be careful with your sign rules. A positive times a negative number is negative 175. In order to solve for x, since it's multiplied by 14, I need to divide by 14. That will give me the x by itself. But if I divide the left side by 14, I also have to divide the right side by 14. So be careful here because this is a number, minus 175 over 14. But we can show that that's not in lowest terms. You might look at 175 and say, hey, I think that's only divisible by 5. But if you do the prime factorization and show the factor tree, you can show that the prime factorization of 175 is actually 5 times 5 times 7. So it has a factor of 7 in there. And you can cancel a factor of 7 not only from 175, but also from 14. So if I cancel that factor of 7, I'm left with just 25 over 2. And don't forget that number should actually be negative. I'm going to rescan it before I actually post that. But if you have a negative divided by a positive, of course it is negative. And that's an important lesson of why you have to really be careful when you're trying to, when you're showing your work, particularly if you're in a rush like me and you wanted to get these videos up quickly before the end of the day. So we'll have our next set of videos on the idea of conversions between the different representations of percents, decimals, and fractions.